So let's consider a particle that is forced to live between x equals 0 and x equals L. And let's consider different t equals 0 wave functions. And let's ask the question, what possible values of energy could we obtain in a measurement? So let's say the function looks like, let's say that c is just some positive number. The function psi of x and 0 is just c for values of x such that x is in this range and 0 otherwise. And let's consider a different function where psi of x and 0 is equal to c for x in this range and minus c for x in this range. Let's plot these functions. So let's look at this function. What does that look like? So we have psi of x and 0. This is 0, this is L, and this is L over 3. 2L over 3. And the function is just c, and c is just some positive number. So this is c. So from here to here, it's just c, and then it jumps down to 0. So it's discontinuous. And in this case, we have psi of x and 0. And we have 0 here. This is L. And this is L over 2. And this is c. And that's minus c. And so we have that the function looks like that. Let's put 0 otherwise. So the function quickly has to transition down to minus c so that it can be minus c for all values just past L over 2. And then it remains at minus c until it goes rapidly to 0 at L. So that's what the functions look like if we plot them. And what we want to consider are what possible Cn values we could get. Of course, the Cn values for these different functions is always given by this quantity. Right, we'll break it up into the different components, different energy eigenfunctions. So in this case, this would look like c root 2 over L, integral from L over 3 to 2L over 3 of the psi n stars, which are the same as just the psi n. So it's sine of n pi x over L in dx. And in this case, the Cn's would look like, well, it's only c here, and it's not 0 here, so we have c times root 2 over L, integral from 0 to L over 2, 0 to L over 2 of sine n pi x over L dx, plus the next one, which is the minus sign, so minus c, integral from L over 2 to L of the same thing, of course, these functions have the cosine of n pi x over, or minus the cosine of n pi x over L as the result of the integral. This one comes in with a positive sign, but we don't really have to worry about the details because, if our question is what possible values of En we could get in a measurement. Right, so what possible values of Cn contribute to this? And the answer comes from the fact that these eigenfunctions, the Cn's of x, have a definite parity. So this function is even about the midpoint. So where's the midpoint? Right here. And the function on this side looks exactly the same as this one. So only the even functions contribute to, it's still an infinite sum, but it's n equals the odd n values. Those are the even functions. It's an infinite sum over those values. So you can never get a value of energy that corresponds to n equals even for this function, whereas the opposite is true here, n equals even, because this function is an odd function, right? You flip it and you multiply by negative sign and you get this side. And so it's made up of an infinite sum of the even n functions. And that would have to emerge from these calculations. We would see that n odd are the only contributions to this one. It's an infinite sum of odd n's. And here we would only get an infinite sum of the even n's.